Welcome to the physics class, BSc Physics, 3rd semester, paper name Geometrical and Physical Optics, Electricity 1 and Basic Electronics. In this paper, unit 3rd, Theory of Dielectrics and Moving Coil Galvanometer. In this 6th session, we will study about relationship between D, E and P. So, here D is the electric displacement vector and E is the electric field or electric field intensity. P is the electric polarization P. So now we studied about electric intensity. Electric intensity is at any point of an electric field is numerically equal to force experienced by an unit positive charge. At that point, his field will be placed. The direction of the E is same as that of electric field. So, the electric field intensity, it is in the direction of the applied electric field will be obtained. The unit of force is Newton and unit of Coulomb is charge is in Coulomb. Therefore, unit of electric field intensity is Newton per Coulomb or volt per meter. Next we see about an dielectric polarization. So in this dielectric polarization, when dielectric slab having an thickness small d is placed in an external electric field, external electric field will be applied into this dielectric material, is placed between the two parallel plate of the capacitor and two parallel plate of the capacitor, charged capacitor, induced charge Qi will be developed. Induced charge Qi will be developed on the produced on the opposite faces of the dielectric. So in this space, positive charged capacitor plate will be formed as a negative charges, and in this place negative charged positive charges will be formed of the induced charges. The in this place dielectric will be gets polarized. Induced electric dipole moment Pi will be produced. Induced dipole moment Pi will be produced in the dielectric. It will be opposite to the direction of electric field. The electric dipole moment induced per unit volume is called the polarization in dielectrics or electric polarization of the dielectric. It is represented by an vector P. In this vector P which is equals to, when vector P is equals to dipole moment small p dividing by per unit volume. So small p in certain textbook they will be represented as in mu. This mu is equal, mu or small p dipole moment which is equals to charge into displacement. So displacement is the small d. Qi is an induced charge will be developed inside of the dielectric per unit volume. V is an volume of the dielectric, and P is polarization vector is always directed from minus Q to plus Q. The magnitude of the polarization vector is P is equals to Qi into D dividing by V. So volume will be replaced by area into distance, area into thickness of the slab. Here D and D will be cancelled. We will get the polarization vector is induced charge per area. So in this polarization vector is equal to sigma p. Sigma p is the surface charge density due to an induced or bound charges. Sigma p surface charge density, it is a ratio of charge per area. The unit of polarization is Coulomb per meter. Therefore, now we see the electric displacement vector. Consider a polarization of the dielectric slab between the plates of the charged parallel plate of capacitor. Parallel plate of two parallel plate of the capacitor. Here, without dielectric slab, it has an air vacuum. Obtaining the surface charge density sigma free of the capacitor plates, and sigma p is the surface charge density or bounded or polarization in between the parallel plate capacitor. Dielectric will be placed. It produces a polarization. This surface charge density is sigma P. The magnitude of the electric field between the plates of the charged capacitor without dielectric, in the absence of polarization, EO is equal to sigma free dividing by epsilon naught. Sigma free is the surface charge density of the free charges. Epsilon naught is the absolute permittivity. The magnitude of the electric field between the plates of the capacitor with dielectric or the polarization is electric field due to the polarization is equal to sigma p dividing by epsilon naught. Sigma p is the surface charge density of the polarized charges. Net electric field obtained in the dielectric, which is equals to E is equals to applied electric field differences between applied electric field to the polarized electric field. Applied electric field is the sum of net electric field and the polarized electric field. Applied electric field is equal to EP will be changes into the sigma p dividing by epsilon naught. Sigma p is equals to P. In case of polarized vector, already we have to prove that one in this equation. That's why sigma p is becomes an P dividing by epsilon naught. Multiply this equation on the both side of epsilon naught, we will get epsilon naught into E naught is equal to epsilon naught into E plus P. E epsilon naught will be replaced by n sigma free dividing by epsilon naught, and this in this case epsilon naught and epsilon naught will be cancelled. We will get the P. In this case epsilon naught and epsilon naught will be cancelled. Sigma free will be equals to epsilon naught into E plus P. Sigma free is equal to electric displacement vector D. Therefore, D is equal to epsilon naught into E plus P. In this case, the term epsilon naught into E plus P is E plus P. It is a special significance for the electric displacement vector D. This is the relationship between displacement vector, electric intensity vector and the polarization vector. This is the proof of relationship between D, E and the P. Until this one, this is a derivation. After that, in the examination 2 marks they will be asking. So in certain relationships between the electric vector and the displacement vector. We know that displacement vector D is equal to sigma free. It is a ratio of charge per area. In this equation, multiply and dividing by right hand side epsilon naught into K. This whole term Q dividing by epsilon naught into K A, which is equal to applied electric field. It is replaced by an electric field E, and epsilon is equal to, we knowing about that epsilon naught into K. K is an dielectric constant term. Therefore, finally D becomes epsilon naught into E. This is the relationship between electric field vector D and the displacement vector D and the electric field intensity. The unit of D and electric field displacement vector is coulomb per meter square, and polarization it also has same unit. Next we see the relationship between polarization vector and the electric intensity is, already we knowing about that in relation. Epsilon naught is equal to E naught is equal to E plus P dividing by epsilon naught. Multiply this by epsilon naught on both sides. We knowing about in dielectric constant, it is a ratio of applied electric field to the net electric field. So epsilon E naught is equal to K into E. This term will be applied into this equation. We will get epsilon naught Ke, which is equal to epsilon naught into P, epsilon naught plus into E plus P. So rearrange this equation. P is equal to this term. In these two terms, epsilon naught into E will be common. We will get this equation. So here no dielectric is present. K is equals to 1, P is equal to 0. In this case, that is correct, because in the absence of the dielectric between the parallel plate capacitor, there is no takes place of the polarization. In case of presence, there will be obtained polarization. Dielectric will be present, polarization will be present. P is equal to epsilon naught into chi E into E. Here P dividing by epsilon naught into E In this equation, P dividing by epsilon naught into E, which is equals to K minus 1. K minus 1 is equal to chi E. Chi E, it is called as an electric susceptibility. This is the relationship between dielectric constant and the electric susceptibility. Is already we knowing about one polarization term. P is equal to epsilon naught chi E into E. Already we proved that epsilon naught into K minus 1 into E. In this case, we will get the relationship between K and the chi E. K, dielectric constant, is the susceptibility plus 1. Next, in this class we have learnt about an D and EP relationship. Is D is equal to epsilon naught E plus P, and also D is equal to epsilon naught epsilon R into E, because epsilon is equal to epsilon naught into epsilon R. Next, P and the E terms. P is equal to epsilon naught into epsilon R minus 1 into E, and P is equal to epsilon naught into K minus 1 into E. K is equals to epsilon R, dielectric constant, or the relative permittivity. Next, in this term we will getting the new term, that is electrical susceptibility. Chi E is defined as an dielectric material is placed in an electric field and it becomes an electrically polarized. Dielectric field is placed into a capacitor. It will be in an electric field. It produces an electric polarization. In an isotopic dielectrics, polarization vector is proportional to applied electric field. Polarization will be depends on applied electric field intensity. This proportionality term will be removing, the constant term will be added, epsilon naught into chi E. So chi E is the electric susceptibility term. This is the relationship between chi E and the dielectric constant. Thanks for watching this video.